Welcome to 7.4. I know you guys are excited, and so am I. So let's get started. This is all about properties of similar polygons, like the many-sided shapes. We're going to be dealing with all kinds of things like triangles, quadrilaterals, and maybe even some 5 or 6-sided shapes possibly. But just kind of keep in mind that it's all about things we've already discussed. Most of this lesson you should know. So I'm hoping it'll just be somewhat easy and kind of a review of what we did for 7.3. So I want to do this first little thing. I want to start with this right here, this real world link right here in the middle of the page. You hopefully are on page 545 in your book. If not, pause the video and get to page 545 in your book. And we're going to look right here at this real world link. Elsa is printing pictures at a photo kiosk at this store. And she can choose between 4x6 prints or 5x7 prints. So we have these pictures that are like this. And I want to kind of just draw these pictures because that always helps you guys. So here would be like a 4x6. And then we would have something that looks like this. And here might be a 5x7. Okay, and it says, are the side lengths of the two prints proportional? So what I want to point out is this type of thing. I want you to remember that we're going to do the two shorter sides and make a ratio. I'm going to do the, I'm going to start with this. I'm going to put this one on the top and this one on the bottom. So top and bottom. That means I'm going to put this side of 5 over this side of 4. I'm going to make a ratio of the two widths of the picture, so to speak. And I'm going to see if that equals the two lengths. Well, again, I'm going to put this length, 7, over the length of the other picture, 6. And I'm going to ask myself, does 5 divided by 4 equal 7 divided by 6? Well, 5 divided by 4 is 1.25. And 7 divided by 6 would be, let's see, 6 goes into 7 one time with 1 left over. So, and then we'd have a 1. We have a z. Let's see. Let's do it. I just didn't do the math. 7 into 6. Sorry, 6 into 7. Totally did that wrong. 6 into 7. Let's see. So 6 goes in there once with a remainder of 1. And then it goes in there another time. Oh my goodness. Sorry, I'm just really messing up here. And then 6. And then, there we go. And then I'm going to have 36. Anyway, so when you divide it out, this is what you get. Should just have done a calculator. Okay, so are these equal? Well, as you can see, they are not equal. 1.25 does not equal 1.16 repeating forever and ever. So these are not proportional. No, because the ratio of the sides are not proportional. Okay, that's just kind of a quick little review, and that's what we've already been doing. You've been doing most of this, which is kind of nice. So hopefully you'll realize that a lot of this is review. So let's go ahead and turn to page 546. And again, we have already done this. If two polygons are similar, we've already talked about this. Their corresponding angles are congruent. We talked about that Friday. And the measure of their corresponding sides are proportional. So we've already done this. I want to point out this symbol right here. This is a different symbol. This symbol equals congruent. Okay, the symbol above it without the equal sign, this means similar. Okay, so please just keep that in mind. There's the difference, congruent, similar. Okay, so what they've done down here is they have told you that angle A is congruent to angle X. So I'm going to use my little arc marks. You may already have them. I'm not sure if your book does or not. And angle B, I know is congruent to angle Y. So I'm going to put 2 marks there. And then angle C is congruent to angle Z. So I'm going to do my 3 marks there. Okay. The corresponding angles are congruent, but the sides are proportional. So notice they did side AB over side XY. And then they did side BC over YZ. And then they did the measure of AC over XZ. And they're saying that if I put those ratios like this, they would all be equal. So there's the key concept of similar polygons. And if they have the same shape and their sides are proportional and their angles are congruent, then they are similar. So right here, it's wanting us to find out if these two rectangles are similar. Okay, they're both rectangles, so they have the same shape, so we might assume that they are similar. However, we have to compare the ratios of the sides. So let's compare our widths. We have our width of 6 and our width of 3. So let's put 6 over 3 and ask ourselves, does that equal the ratio of our lengths? And I'm not going to do this length to this length. I'm going to do this side because these are my correspondings. So I'm going to put 10 over 7. Does 6 over 3 equal 10 over 7? Or another way you can look at it is this. This would be a really easy way to look at it if you can see it. I know that 3 times 2 is 6. So 7 times 2 should be, ooh, if these were proportional, this side would not be 10, it would be 14 because 7 times 2 is 14. The scale factor, again, has to be the same. We have to increase the length of both sides by the same scale factor. So these are not similar, and there it proves it to you down there. And it's showing you that the ratio of the sides, we have 7 over 10. They did the smaller shape to the larger shape. Does it matter? I did the larger to the smaller. It doesn't matter as long as I can see that 7/10 does not equal 1/2. They are not equivalent. So therefore, the rectangles aren't similar. So pause the video and do the got it problem below and check your answer when you're done. Okay, I'm going to tell you, I can't see anything. I don't know 6 times 8. I don't know 6 times what is 8 and 8 times what is 12. I don't know that, so I'm going to have to create the fractions. So I don't know if you want to do smaller side to bigger side. I'm fine. But let's find our corresponding sides. And I'm looking at this, and I'm going to say that these are my two shorter sides. Same thing here. So these two sides correspond. And then my AB and my XY side correspond. So I'm going to put AB over XY. Side AB over side XY. Okay, I'm just going to put those over each other. And I'm going to reduce this to 2/3. Okay, and then I'm going to put side BC over side YZ, and that is 6 over 8. Excuse me, 6 over 8. I got to look at these. Okay, 6 over 8. And 2 goes into both of these. So 6 divided by 2 is 3. 8 divided by 2 is 4. Well, one ratio is 2/3 and one ratio is 3/4. They are not equivalent. So, sorry. So I would say no, the triangles are not similar. And while they look very similar, again, remember, they look similar, but we have to mathematically show that they are similar. So hopefully when you checked your answer, you got the right answer. Let's go ahead and move to page 547. And we're going to actually learn how to find scale factor using the scale factor, which right here, I've been telling you this. The scale factor is the ratio of the lengths of two corresponding sides of similar polygons. So if you prove that they're similar and their ratios are equal or proportional, then you have your scale factor, and you can use that to find missing side lengths. So here's what they've done. So it wants us to find the length of AB. What the heck is the length of AB, it's asking. And maybe we could also find the length of WZ. So we look at these shapes. They look like they're going to be similar. Oh, maybe they want us to find, sorry, they want us to find XY, but we could find any of them. We could find any of these lengths. So they're telling us that they are similar right here. They are similar. So let's find the difference, or the scale factor, not the difference, but the scale factor between this side and this side. So I'm not sure how you'd rather do it. If you want to do it, let's do larger. Again, it doesn't matter as long as you keep it proportional. The length of ZY over the length of DC. Okay, I'm going to show you one way we can do it. We can set up a proportion. So let's do 15 over 10. Now, I want to show you that I did large shape over small shape. Okay, so my large side is the one that's missing, so put an M right there. And this side we know that's corresponding, side BC corresponds to XY. So I'm going to put that here. So now I have corresponding side of the large shape over the corresponding side of the small shape. So 15 is to 10 as M is to 12. So these two ratios should be equal. So let's figure that out. First of all, let's reduce. Let's reduce this. 5 goes into both of these. So let's reduce this to 3 over 2. Okay, I divided 15 by 5 and got 3. And I divided 10 by 5 and got 2. And now let's just copy this one down. All I did was reduce. Just reduced it. Makes it much easier. I can look at this problem now and I can see that 2 times 6 is 12. That means M would have to be 3 times 6, or the side length of M would be 18. Now let's see if that makes sense. If M equals 18, 12 to 10, okay, these are smaller, 18 and 15, okay? This should be larger. This should be 1.5 times bigger, and it is. Missing side, that's it. Once I know the scale factor. Now what they're telling you down here is this. And this is another way you can do it. I want to show you what they've done down here. Okay? What they did down here is they did exactly what we did. They did 15 over 10 and they reduced it to 3 halves. So they knew this was our K. So then what they did is this right here. They knew that our missing side would be our scale factor of 3 halves times the corresponding side of the smaller figure. So that's also what they could do. What another way you could do it. Take your scale factor times the side you know, the corresponding side of your missing side, and when you multiply that, you get 18. So either way, you get the same answer. I like setting up a proportion because to me, a proportion makes a lot more sense. Big side to small side equals big side to small side. Okay? All right. That is, I think, what they did below. Here's one way they did it. Here's the proportion. So here's what they're showing you. Exactly what we did. Big side to small side, big side to small side, and corresponding sides. Okay. Here is what you need to type in for your answer. You need to type in the missing measure for WZ and AB. So type these answers in. I'm going to go ahead and try to help you set it up. We have these shapes. Look, they're even letting us use the same measurements. We've already found M, but now we're going to find this, and we're going to find this. So we know that we have 15 over 10, which equals 3 over 2. So you choose whichever way you want to do it. Okay, I'm going to have you start. Let's make these different colors. I'm going to have you start with the first one, which is B. So let's start with B, and we're going to call this B. And we're going to call this one C. Okay, just like M. We've already found M, so let's find B and C. All right, so B is what we're missing right here. That's our big shape. And the corresponding side to B is over here, 13. Okay, so now I've set it up for you. Ooh, that's not very pretty. So hopefully you guys know how to cross multiply and find proportions. So you're going to end up with a decimal on this one, and that is okay. Okay, you're going to end up with a decimal on this. So here's what you can do. You can do 13 times 3 and divide it by 2, and that'll give you the answer to B. So 13 times 3 and get an answer, and then divide that answer by 2. Okay, 13 times 3 is 39. Divide that by 2. That's going to be your answer for B. Okay, let's find C. So this time again, we have our 3 halves. We're going to use the same one we know, the scale factor that we know. Okay, and we can set up C. This time, we don't know the smaller side. So we do know the bigger side. Here's the bigger side. But the smaller side is missing. So now you can look at it and go 3 times what is 24. So 2 times what? You can do that. Or you could always do 3 halves times 24. Use your calculators. Get those 2 answers. Type those 2 answers into Canvas to submit your assignment. And then you can do your assignment out of your book. And you can work with a partner if you would like. But I will have those answers for you in Canvas tomorrow where you can check your answers. Your assignment is page 549 and 550, numbers 1 through 11. Do all 11 problems.